from -1 to 4, prove that the function f, shown below, there is some c such that f of c equals -3. Justify your answer. Now, what is the condition we have to use intermediate value theorem? What has to be true about the function before we can use the intermediate value theorem? Continuous. So, is this function continuous everywhere? It's not continuous everywhere. Where does it have a discontinuity? 5. Is that between -1 and 4? No. So, we would say f of x has a vertical asymptote at x equals 5, but is continuous everywhere else. So f of x is continuous on the interval from -1 to 4. And so basically what we need to know here, if we're kind of thinking of like a graph of what we need to know, from -1 to 4, so let me draw that graph again. I need some. From -1 over here to 4, we want to see if our function ever equals -3, right? So intermediate value theorem, the information we need to know is where our endpoints are, right? Because if our endpoints, if one of them is above and one of them is below, then we know it's got to cross -3 there. So we're just going to plug in -1. So we'll get -1 squared minus 9 over -1 minus 5. So that's going to be -8 over -6. So that will give us 4/3. So at -1, we're up here at 4/3. We also need to know the other endpoint. So we'll have 4 squared minus 9 over 4 minus 5. That will give us 16 minus 9, which is 7 over -1. So we get -7. So 7 is over here. And so intermediate value theorem tells me that if I'm going from up here to down here, right, and my function is continuous, at least once, I've got to cross that dotted line at -3, right? I got to have a y value of -3. Might happen more than once, but it definitely has to happen at least once. So we can say by the intermediate value theorem, since. Now, careful right here. Which value is lowest? The second one, right? So we need to say f of 4 is less than -3, less than f of -1. And we have shown what those values are up here, so it's okay to do it this way, right? You would not want to just write this without showing that you actually found what those values are. But we know the f of 4 is less than -3, and that's less than -1. So since we know that is true, there must be an x value C such that f of C equals -3. Oh, careful. Where has it got to be? There must be a, oh, yeah, must be x value C on -1, 2, 4. That, you do have to say that, so make sure you include that. Because this would not be true for, like, forever, only on this interval. Especially for this function, because it does have that discontinuity at 5. So if you had an interval that included 5, you would not be able to apply intermediate value theorem. You'd have to say no to that. Okay, so just to highlight here, the key points, you got to have continuous. You must say that it's continuous. You must find the values for the endpoints. Intermediate value theorem, got to show that the value that you are looking for falls between these two endpoints. And then your conclusion here. So if we want to kind of like write that out, we got to have always continuous has to come first. Then values at endpoints. Intermediate value theorem, IVT, but I prefer you to write it out or you'll forget what it stands for. Then you got to say f of A less than value less than f of B. I'm just generalizing there. And then conclusion, which is going to be x value on the interval from A to B, such that therefore such that this line right here, just draw like a long vertical line. That means such that. That's mathematical. So if you want to do that, you can. F of C equals value. So those are the things we need for intermediate value theorem. If you're missing any of those pieces, then it's not going to be complete. Mm-hmm. This is why I would really like to be an AP grader. I have applied, but they have not chosen me yet. So I'm hoping that maybe this year I'll get to be an AP grader. So I am not 100% certain about like how that would be on free response for the AP exam. It is good practice to mention it there because I would rather be more cautious rather than less. You could probably, I think, get by with just saying it's continuous on this interval. But when you tell where that vertical asymptote is, you're showing that you didn't just like blindly believe it, that you actually considered that. So I'm not certain about how an AP grader will do that, but to be cautious, I would put it there. For me, I would like to see it. I generally, if I'm unsure about something, about how they would grade it on the AP exam, I generally try to go conservative on that and make you guys show more work rather than less, because if I'm wrong, you're still going to be okay because you'll have all the things that you need. Whereas if I'm wrong and I let you by with stuff that you shouldn't get by with, then there's points that we're losing. So that happens. Okay, let's look at a multiple choice question. So we've got f of x equals x plus cosine of x over 5 minus 3. The intermediate value theorem applied to f on the closed interval from -9 to 4 guarantees a solution in -9 to 4 to which of the following equations? I believe this was calculator active and I forgot to put a calculator next to it. It's got to be. Because our endpoints are -9 and 4, and we do not know how to find cosine of -9 and 4 without. Pretty sure, was this calculator active? There's a chance it's not. Let's look at how, so if it's calculator active, you just use the calculator plugged in these values, right? Let's look, just in case it was in calculator inactive, I can't really remember right now. You can kind of do this, maybe. Let's see. So if we're doing f of -9, we'll get -9 plus cosine of -9 fifths minus 3. So obviously without a calculator, you can't figure out what that is. With a calculator, we can just say -9 plus cosine of -9 over 5 minus 3. Make sure you hit the green button before you hit enter. We're going to get -12.2272 right there. If it's not calculator active though, what's the lowest cosine of -9 over 5 could be? -1. So that would be -9 minus 1 minus 3, which would give us -13. What's the highest? It would be +1, so -9 plus 1 minus 3, which would give us -11. So this would give you like a range of where that falls. We know that value's somewhere between -11 and -13. So it's possible this could be calculator inactive, I think. F of 4. We'd have 4 plus cosine of 4 fifths minus 3. And if you do that in the calculator, am I doing that right? Oh, no. Alright. Oh, green button. Alright, I get 1.69671. If we think, again, that lowest and highest, in case this shows up calculator inactive, that'd be 4. Lowest that could be is -1 minus 3, which would give you 0. Highest would be 4 plus 1 minus 3, which would give us 2. So, calculator active, you know the exact values. Calculator inactive, we know we got somewhere between -13 and 11 and 0 to 2. And I would also, I know that cosine of 0 is 1, right? This does not equal 1. So I know it's not actually the highest, so I know it doesn't equal 2, like this.
So it's really close to cosine of 1. Couldn't you estimate that it's between 0 and like decimal point? Because cosine of 1 equals 0, and it's towards 1.
Cosine of 1 is not 0. Cosine of 0 is 1. Right, so this is cosine of 0 right here, where you got 1, 0. And then, like, this is pi over 2. Pi over 2 is half of 3.14, so that's like 1.7 something. So cosine of 1 is like around here. Cosine of 4 fifths, it's like about here. But we do know, so if I'm thinking of how to do this without a calculator, I know that that value that I'm looking for, I know exactly that it needs to be negative 12.2272 less than the value less than 1.69671. So with the calculator, I know whatever f of c value I'm looking at needs to fall between these two numbers right here. What's the only one I've got that falls between in that range right there? It is b, 0. If this was not calculator active, the lowest I've got is 13, the highest is 2, but I do know that this is not actually going to equal 2, because the only way it would equal 2 is if this was actually 1, and I know cosine of 4/5, even though I don't really know what it is, I know it's not 1. Because for it to be 1, it would have to be like cosine of 0, right? So it's between 0 and 2, it's not actually going to be 2, so I would not consider this. You would still make that same conclusion that it would be B for that. Yeah, I can't remember if that was calculator active or not. It's much easier if it is calculator active because you don't really have to think about what those values could be. But all of these are not applicable because these values do not fall between those values of your endpoints. There. Okay, does that make sense? All right, so let f be a function such that f of negative 3 is less than 9, less than f of 6. Which of the following statements provides sufficient additional information to conclude that there is a value x equals c in the interval from negative 3 to 6 such that f of c equals 9? All right. Hold on just a second. I think I know the answer, but I'm second guessing myself here. Oh, that's not what you have. You don't have a continuous stick. Oh, I typed it wrong, I guess. That's supposed to say continuous right there. That's what I was really thinking. I was trying to decide which one. Sorry about that. That is a typo. Now, which one do you guys think it is? It would be C here because this is intermediate value theorem, right? F of negative 3 less than 9 less than f, where we're looking for a x equals c value such that s of c equals 9. This is basically just told us all of those conclusions of the intermediate value theorem. But before you can apply intermediate value theorem, you must know the function's continuous. It does not matter if it's increasing or decreasing, because this function, I mean, it does, for this to be true, you do know that you've got like your point right here, you know, your point at negative 3 is the lowest and the point at f of 6 is the highest, but it can do all kinds of crazy stuff in here. It could increase and decrease and still be true. So continuous is the one here. This right here tells you about a limit existing. Limits, do we have to be continuous at limits? Does your function have to be continuous at a limit? It does not. What could you have and still have a limit? Hole in the graph. If you have a hole in the graph, this intermediate value theorem does not apply. So this one does not have to be here. Okay. On the interval from 0 to 4, the function f shown below must have a value x equals c such that here and this is similar to that last problem we did. We need to know the endpoints. So this is certainly not calculator active. We can find this So we would have 2 over negative 2, which is negative 1. So we get, let's see, before 6 over 2. It's 3. What do you guys think? Okay, 2. It's not. I actually realized this right after I flew in on this problem. It is not 2. It's not B. Why is it not B? You have a hole in this graph at x equals 2. We got discontinuity. Does the intermediate value theorem apply? No. You cannot determine a C value because it is not continuous. I put that problem here specifically for this reason, but as I was looking at it, because I haven't seen it since last year, I just flew in on the problem and would have probably put B if it had not hit me there that this is not continuous. So that first thing we always check for this is continuity. So you want to watch out for that. All right. So your assignment. Let me look at the book and make sure this is what I want to give you because you also have that progress check. We might do odds. Yeah, I think we'll be okay just doing odds here because it's pretty repetitive. So these are all intermediate value theorem problems. These ask for zeros. So they're asking you to show that there has to be a 0. So that means that your f of c will equal 0 for the intermediate value theorem. These right here, they're going to tell you what value. So they'll have f of c equals some number out to the side. So just do the odds on those. I think it'll be like 4 problems for you there. And then we also have the Part C progress check. So those are your 2 things that you'll be working on for me.